Hello, this is Roberto and this is the HVAC my channel. Today we're going to be talking about dedicated outside air system, DOAS part 4, air distribution configuration. Alright, so let's get into it. So to begin with, I'm going to put this in pink. So in pink, in the previous video we've been talking about number 1 and number 2 configuration, which is directly to zone to a space and intake to the HVAC unit, okay? But now this depends always on the designer because see, as you can see, this is 1, 2, 3, 4. All of them has advantages and disadvantages. So in my experience, I've seen a lot of number 1 and I've seen number 2. I have seen some of the number 3, but I've seen some in number 4. So number 3, I haven't seen that so much. But however, DOAS connected to the outlet of HVAC unit. So as you can see in here, I'm going to put this in, yeah, let's put like this. So this FCU, as I've been mentioning in my previous video, and forgive me for my redundancy, the FCU is the local HVAC unit, right? At the local HVAC unit, and because it's the local HVAC unit, all right, this pretty much does recirculation. But at some point we need to mix outside air, right? So there are different ways of mixing outside air. So in this case, instead of putting in the backside, in the inlet, we're going to put it on the outside. So this is the VAB. And as everyone remembers, in the VAB box, actually the requirement for this space, I'm going to put this in yellow. So this is the conference room, right? So I'm going to put again in here conference room. So the requirement for the conference room was an outside air of 75 CFM, right? 75 CFM. Okay, so technically we're inputting 75 in here, 75 CFM, right? And this is going to get mixed by this by the FCU. However, this is very interesting because based on the balancing, let's think about this. What is the SA supply air, how much it is? So if you add this 100, 90, 90, 90, that's going to give you 370 CFM, okay? And why am I making this? Why am I making this math? Because we need to know how much CFM I'm going to size this grill for. So this grill is going to be my return air. So the return air is going to be for how much? Let's see in here. So in here we have 370. Okay, 370. However, 75 is coming from here. It's tapping from here. So the total RA to be sized is going to be 370 minus 75. So that's going to give me a total of 295 CFM. All right. So let's do this in other words like this. I'm going to use another diagram. So whichever diagram is more convenient for anyone, for the designer, that's the one that you have to follow. But if I do this, for example, let's do this like this. I'm going to make a diagram in here. So I'm going to put in here my FCU. See, this is my FCU right here. And then I'm going to have my, in here like this. So I'm going to have my inlet. I'm going to have my outlet right here. See, outlet, inlet, outlet. And then I have my inlet in here. See, I'm tapping in here to the outlet. All right, so this is going to be outside air. So how much is outside air? We're going to go here and then we can put in here, this is coming as 75. See, 75. And this is coming in as we don't know yet, but this is coming from the return air, right? There you go. I'm going to put this like this. Okay, so this is coming from the return air. It's getting into the system. See, return air. Okay, so this is 75 and this unit has to give me how much? So after you mix this, see, 90, 90, 90, 90, it's going to be 370. So 370 is including the outside air. So 75 plus 370, which is not a good idea. So technically in here, what I have for my outside air is going to be 295. See, why is it 295? Because 295 plus 75 delivers, which is what I want, delivers 370 CFM. This is mainly interesting for balancing purposes. So 370, we're all good. But as you can see, after the FCU, I'm going to put in here the local HVAC unit FCU. It's going to be 295, right? So 75 and then 370. So technically this is getting in here because there is only one fan, right? The fan is not gonna give me in here. I give you like 200 and then I give you 295. The fan is only one. There is only one fan in here. So the fan is either gonna be running, I'm gonna put this like this, either in low, medium, okay, medium, or high speed, right? But also I'm gonna put in here something extra because this always, if you wanna verify this, you can always contact representative. It's funny, we always call it like contact rep, sales representative. So this could be like, you know, Train, Daikin, LG, but I'm not sure if LG is doing good. So Carrier, you know, yeah, some of the common representatives. Okay, so for example in here low, medium, high. So how am I gonna make this? So again in here it's gonna be 295 and this would be sized for 295. I'm gonna put in here this 295. There you go. So recirculation 295, 295, and then in here we're tapping 75, 370, and then we have everything in here good. And again, before I forget, I'm gonna connect this to the BAV. That's the form of control of the BAV because it's a conference room, demand control ventilation, or depending on the occupancy, right? I'm gonna put in here, depends on occupancy. I'm gonna put that in white. See, depends on occupancy schedule, occupancy schedule, all right? Alrighty, so since we have this, I'm gonna show you very quick like what I mean by low, medium, high. So for example, if we go here, I'm gonna put this on this side of the screen, see? Right here. There we go. So if we examine this is the unit, right? So if I have this unit, PEF P12, we said that it's gonna be 1 ton, medium static ducted. Okay, I don't have so much duct work. So this is the FCU actually, see? FCU and refrigerant lines, condensate line, and then for this, what are my speeds? I'm gonna put in here, see, airflow rate. It says airflow rate. Under the airflow rate, I have the CFM. The CFM in here, it says 265, 318, and 375. So possibly you wanna put it in medium speed, 318 CFM. You know, and then you can always change this to high speed. So that's what you have to analyze. Okay, alrighty. So that's number 3, DOAS outlet of HVAC unit, and this is pretty much how it works. Okay. Some advantages and disadvantages. Actually, so whenever we're tapping directly, we're avoiding actually the space. So we don't have to have another diffuser, another type of ductwork. So this saves costs. All right. So disadvantages. The disadvantage is that even if you're this FCU is going to have to be working because this is tapped in here, so this might be working depending on the schedule of occupancy. So sometimes the FCU cycles on and off, but in this case it's gonna work more. Okay, so I'm gonna put in here the fan. This is one of the disadvantages. Works more, and then it doesn't cycle on and off like before. So it pretty much works more consistently, which is so increases the price, right? So more price for energy, right? For heating and cooling, and then longevity, right? So anything works a lot, so that could be affected. But on the other hand, the advantage of this system is like we avoid duct work so much. Okay, so I'm gonna put in here cons maybe, and then I'm gonna put in here pros. Possibly I'm gonna put less duct work, right? And then I'm gonna put less diffusers. I mean, in this case, it doesn't seem to be too much, right? But whenever you're talking about a big building, office building, community center, you multiply these times maybe 20 or times 30, depending on the size of your project, and then it adds up. The cost adds up. All right, so that's why. Now let's go to the other side. So this is, I'm gonna put this in pink again. In pink, this would be DOAS. So DOAS directly to the ceiling plenum. All right. So pretty much you are pressurizing the ceiling plenum. And again, I'm gonna make in here some explanation very quickly. What is the ceiling? So in this case, if we see this as an elevation type, so this is like this, like this, like this, and then you will have your unit right here. So I'm gonna put this right here. So so your unit is like this, right? And this is the FCU. I'm gonna put in here FCU, FCU, and this is space. This is the ceiling. Okay, so this would be the deck, or I'm gonna put like this, like this. Let's put like this, like that. Okay, so I'm gonna make it like that. Slab. Let's put a slab, for example, slab or deck. Yeah, slab to slab, deck to deck. See, this is slab. Okay, so this is space in between, so it's called the ceiling plenum, right? So I'm gonna put this in here as white. This is ceiling, okay, ceiling plenum, which is very important to coordinate with the architect early in the design, because usually I ask like maybe 20 inches plus at least. Sometimes the architect wants to give me 14 inches, 15 inches. So it's very good to be open, being honest at the beginning, because I've seen projects in the beginning like, hey, I'm gonna give you 14 inches. Oh, and then after that, we'll figure it out. But then after that, it's too late because we're on another, remember the design phases, right? S, D, 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 and then C, D. So it's very important to coordinate an SD level, like a schematic design, because then you are going to avoid a lot of work done in the DD design. So SD is very, very important to coordinate. It's better to get much space, honestly, because then you're going to have the interaction or the clashes with the, plumbing, piping, fire protection, electrical events, so it gets crowded in here. So it's better to have more space. Give it a little bit more, right? All right, so this is the ceiling plenum, and whenever I'm saying directly to the ceiling plenum, it says, so see, my main outside air now, it's dumping all the air in here, so we're dumping all the 75 CFM, see, directly to the plenum. So this plenum is pressurized, see, it's pressurized like this. See, all the air with outside air would giving this 75 CFM. And since this fan, I'm gonna put this in blue, so see, in white. Since this fan is working as recirculation, my recirculation was so 370. Let's see, so 370 CFM. All right. So this gets mixed in here. So automatically goes to the inlet. I'm gonna put this, let's put an arrow here. There you go, arrow. So it automatically goes here to the inlet of the FCU unit. All right. However, this is very interesting. Usually in the project itself, I would put something like a keynote in here. So I'm gonna put a keynote like this, like a rectangle hex note. See, number 1, for example. So if it's a number 1 keynote, I would word it something like, let's see, this is gonna be an open duct, right? So I would put like, let's see, something like in the keynote number 1 right here. See, keynote number 1, provide, let's put this, provide air duct opening. See, air duct opening. See, opening. That's for the drawings, right? For the drawings, and I'm showing you how we would put in the plans. Provide air duct opening with let's put in here, provide duct opening And then let's put in here, provide air duct opening. And then you could include 1/4, see 1/4 inch wire mesh. Wire mesh, right? Wire mesh. And of course, in a project, there's so many keynotes. This is part of our sheets. And also for this, you're going to provide a volume damper right here, so they can adjust everything. All right. So this is one type. So you provide directly to the ceiling plenum, and the other one is to provide this to the elevated floor. All right. So I've seen that other project too. So I'm going to put that in here. So this would be called directly to the, I'm going to put this in pink too. Let's see here. So this is called directly to, okay, raised floor. Raised floor. There we go, directly to the raised floor. And this is called actually, that was funny. That was my cat actually. Okay, to raised floor. Okay, so this is actually called something like I'm gonna put this in here. Underfloor air distribution. Air distribution. And actually, I've seen these projects in mainly libraries, but I'm going to show you a product, for example. So there's a product in GreenHack, and I'm not sponsored or anything by GreenHack, but I was just looking at this. So if you see here, this is an underfloor fan terminal model UFT, energy efficient variable speed reheat. So this is the terminal unit, it's underfloor. So just to give you a perspective, we're gonna put that here. Let's make it bigger. Let's see right here. I'm gonna make it a little bit bigger. There you go. All right, so if we go here, so this is the conventional HVAC unit, as you can see. So we have diffusers, we have return and everything. But this unit, underfloor air distribution, works like this, right? So we have a raised floor, and then we have our units right here. So technically, all of this has to be already pressurized with the outside air. So outside air is going to go to the inlet, and this is going to provide the mixed air already. So as you can see in here, see thermal stratification. So we have the supply air right here. Actually, this supply air is already treated, and this is pretty much heating it up. However, this is the concept, raised floor, not on the ceiling plenum right here, right? So this is pretty much how it looks. So supply air. So in other words, in here, instead of a DOAS, you would have maybe an RTU that already mixes air with heating and cooling, but then it goes as supply air. See, this whole raised floor is already pressurized, and then this provides the final terminal unit. All right, so you can use it as a hot water with reheat or normal air system. All right, electrical, or also this is also see mixing unit, the local HVAC unit. All right, see, this is something is looking like this. So your diffusers are round, circular like this. See, and then on the windows you have like something like a linear. All right, so actually, if someone is more interested in this concept, because I've seen these projects actually, so if someone is interested in this project, I'm gonna leave this in the description below. I'm gonna leave the link for this. And there's also another example, which is a Titus model, GreenHack model, so whichever works. All right. All right, so now that we have covered all of this, so I'm gonna put just in here a little bit more like this. Let's see. So I've seen this so this is mainly for the mechanical plants. I don't want anyone to get confused. Mechanical plants. All right, this one. Okay. So I hope you enjoyed this video. So basically the main goal for this series of videos of DOAS is because you always need in any project outside air. Ventilation is very important. It's paramount in any HVAC project, regardless it is. So because of this is mainly for the commercial, so DOAS is an easy way, very efficient way to provide outside air. So that's why I haven't seen videos that they talk how they distributed this outside air to to the space. So that's why I put these 4 arrangements. And then that's basically, whenever I'm talking about my videos, is based on the experience. I'm not the most experienced person, but I have some experience here and there. All right. So I hope you leave any comment, and then please hit the like button. That helps a lot, and subscribe. All right. I'll see you in the next video. Thank you.